All right, hello everybody. So this is a lab on FHRP, first hop redundancy protocol, and we are going to be using HSRP, hot standby routing protocol. All right, so let me explain the lab here. We have a network here. We have PCA, PCB, DHCP server. We have a primary router, R1, backup router, R2. The R1 will be the default gateway for A and B. We're going to simulate having kind of an ISP out here, and server 0 just means that we're reaching the internet and all. Just a couple of things. First of all, let me show you the DHCP server. So on the DHCP server, I've configured, go to services, DHCP, and you'll see that the default gateway is 192.168.1.1. That's what these devices A and B will receive as their default gateway. They'll receive an IP address starting with 192.168.1.50 is the first address given out. There's a DNS server, but we don't care too much about that here. All right, so let me go ahead and close that. The other thing I want to mention is let me show you PCA here. So I did an IP config, and we can see, yes, it has the IP address 192.168.1.50, and there's its default gateway, 192.168.1.1. So this is router R1, gigabit 001 interface. Its IP address is 192.168.1.1. That's how you read that there. I am running OSPF between R1, R2, ISP, just for simplicity. That's not how you'd normally do it in the real world, but just to make it easy on myself, but just and make sure that we can have complete reachability. All right, let's look at a few things here. So first of all, on the routers, and in the lab, I give you all these instructions. So here's the lab here in case you're wondering. Everything's right here. So everything's right there for you. Okay, but I like to take some time to explain some of it. Well, all of it. All right, so let's take a look at R1, router R1's gigabit 001 interface. That's the interface right here that it has on this network. I'm going to show interface gigabit 001. And what I want to point out here is here's its IP address. Okay, and here's its MAC address on that interface, right? And once again, we already saw that on PC1. Yep, that's the IP address that it's using, that PCA and PCB will be using as its default gateway. Let's do a little verification here, make sure everything has reachability. So over here, I have server 11.11.0.101. Okay, so I'm going to go ahead and just ping that. Ping 11.11.0.101, and it should work. Now, why would it, the first couple of pings might fail? Well, either this device, PCA, or one of the routers along the way has to do an ARP request and wait for the ARP reply. So let's do that again. You'll see that now they all will succeed. All right, let's verify the path that PCA takes, the packets from PCA to server 0 might take. Well, does take. Let's do trace route, and we use trace RT in Windows Simulator here. And what we can see is using that ICMP time exceeded message that trace route uses, that here is the first hop, 192.168.1.1, right here, router R1, that's what we expect. The next hop was 10.0.0.3, that's the ISP router, and then finally the server. All right, that's looking good. We can actually take a look at A's ARP table. So let me do ARP-A. And we can see that when it had packets to send to a remote network, it needed to encapsulate those in the MAC address associated with its default gateway. And if it doesn't have that in its ARP table, it will send out an ARP request. The device with that IP address will send back an ARP reply. And then the device now has the known IP address that it was trying to get the MAC address for, knew the default gateway address, right? Remember that right up here, knows the default gateway address. Okay, just need to know its MAC address. And now it has that. So now it encapsulates those packets with the destination IP address 11.11.0.101 into a MAC address, this MAC address from PCA to the router. All right, so we can even take a quick look here at switch 1 here. The MAC address tables I'm not so concerned with in this lab, but it's kind of just to show you that we can see these MAC address tables. Okay, so we actually, this switch 1 is connected, or the router here is connected to switch S1 on switch S1's fast Ethernet 05 port. And we can actually see that the MAC address associated with router R1, there it is here, and is on FA01. 1302, remember the end of that? Remember right here, there's that MAC address. Oh man, so cool how all of this stuff just fits together. All right, so let me go ahead and I'm going to close that. And I think the next thing we need to do is create a little fail point here. So what I'm going to do is go on router R1 here. Okay. And what I'm going to do is I'm going to shut down this interface here. And watch as soon as I do it, that link light's going to go red here. So let me go interface gigabit 001. Now watch this, shut down. Okay. And we're going to examine some iOS output too. Okay, whoa, shut down. Look at that red link light there. Move that out of the way, red there. Okay, what just happened? Well, we got iOS messages, link change. These are iOS messages. Link change, gigabit 001. Change state to administratively down. Administratively down is shut down. Some other things that happen. Remember I said I'm running OSPF? I have an OSPF adjacency change. The neighbor relationship on this network here went from full to down. Okay, so that's kind of cool to see. Okay, for those of you that I know most of my classes have had OSPF, I mean, not everybody that's watching this video. All right, let's see if we have reachability now to, remember, we're trying to reach server 0 here. PCA's default gateway, we just shut it down, 192.168.1.1. Let's see if I got reachability. I'll do a ping here. And maybe one might fail, maybe two might fail, but all of them are going to fail here. Yes, of course, we don't have any reachability. Matter of fact, I'm going to do a trace route here, another trace route. And we'll verify it that way as well. There's my trace RT. And we'll see that I can't even reach my default gateway because that is the first hop in our path that is down. I shut down that interface. Okay, so I'm going to actually just hit Control C here, get out of this so it doesn't keep on trying. Thank you very much. Okay, I'm going to restore the fail point. I can do that by just doing, I'm still in the interface gigabit 001. I'm just going to do a no shutdown. That's how we reverse things in iOS. Okay, this is, so I'm going to do a no shutdown here. There we go. Let's see. Interface. So it looks like I got iOS message that link change to up. Up, there we go. There's my OSPF adjacency change, and we've gone from loading to full. All right, so this is looking good. Let's see if we have reachability restored. You can see the link lights came up. Let's see if I can reach that server again. Now, depending on how long this takes, certain things might happen, like the might have the entering the ARP table might have timed out. So it might have had to do another ARP request. But it looks like, yes, we do have reachability. All right, looking good. But, all right, so this is a problem here, right? We have actually two routers. Now, if I wanted to use this backup router here, I have one of two things I could have done when I shut down R1's interface. Okay. Matter of fact, let me shut it down again. I'll just tell you what I would have to do. If this interface went down, okay, one of two things. I could go to router R2, okay, and if I do show IP interface brief, okay, it has the address on that interface 192.168.1.2. However, remember my PCs, all my clients, they have the default gateway of 1.1. So which one do I change? Okay, so I could just change this to 1.1. That way I don't have to change all the ones on my my client devices and servers and everything else. Or I could go and change the address on the DHCP server, have everybody reboot, you know, and then they would get the new IP default gateway address of 1.2. So I'd have to do that on the DHCP server. Okay. And actually, we are going to do that, but not here. Okay. Not quite yet. So I could change it there and have everybody reboot. But either way, this is not fun. Okay. It takes time. Maybe, you know, you as the network administrator are not, you know, you're at home or, you know, whatever the case may be, but, you know, time is being lost. Productivity is being lost. The network is down. All right. So how can we have this done automagically? All right. HSRP. Let's take a look. Let's configure HSRP, but let me bring this back up. Oh, shit. There we go. Bring that link back up. And we are going to configure HSRP, Hot Standby Routing Protocol. Okay. So we're going to make R1 is going to be our primary, or known as our active router, and we'll make R2 our standby router. So we're going to go into the interface here, to gigabit 001. Okay, I'm going to add a few commands here. So standby actually means HSRP. All right. We're going to use HSRP version 2. Okay, then I'm going to say standby, and then the group number is 1. So this is going to be the group number both R1 and R2 are going to join on their adjacent interfaces here. Okay, and next I'm going to give a virtual IPv4 address. You can see it right at the top here. This is an address that they're both going to share and will be our new default gateway address that our clients are going to use. And that will be 192.168.1.5. We don't have to worry about the MAC address, okay? We'll talk more about, I talk about that in the lecture, but it automatically gets this MAC address associated with this IP address. Okay, I'm going to do standby, gosh, if I can type, standby 1, same group number. Notice it's going through a phase, it's different states here. Went from init to standby, it's now the active. I'll talk about that in just a moment. But I'm going to do standby 1 priority. So I'm giving this, going to give the default priority for HSRP is 100. I'm going to give this a higher priority so it makes sure that between R1 and R2, this will become the active router. Okay. And I'm also going to do standby 1 preempt. Preempt means if another router is already the active router and this router comes back up or the interface comes up and it has a higher priority, it will preempt. It will become the new active router. It will take over, kind of like a coup attempt there. Okay, these are the states. I talk about this a little bit in the lecture. It goes from init then to speaking state, to standby state, and then this one says, hey, there's nobody else and on this right now, so I'll be the active router, the primary router. All right, kind of cool. Now let's go over here to R2. Going to do the same thing, similar anyway. Interface gigabit 001. Okay, the interface it shares on with this network here, 192.168.1.0. Okay, similar command. I'm going to say standby version 2. I'm also going to do standby 1. Got to be the same group number, okay, which we used on our active router, and same virtual IP address. This is the IP address that our clients, servers, everybody on our network is going to think is the IP. Well, they'll use as their default gateway. Okay, you're going to see it go through some states here. I'm going to, if I don't give a priority, it defaults to 100. But just to show you, I'll give it 100. Okay, that's the default priority. Up, standby, just not standy. Stand by. See this here? Nope, I still can't type. Stand by. Okay, see this caret here? It's telling me it didn't understand this. That's how you read that, right? Okay. Standby 1 priority. And let's do standby 1 preempt. Okay, now you see that it went through similar states, init, then to speaker, to speak, then standby, never active. It's just the standby because it has a lower priority. All right, cool, cool, cool. Love this lab. All right, so let's take a look at some things here. Okay, let's do show standby. Gives me some details on HSRP. We can see this is the interface I've got it configured on. Group 1, that was that group number I was using, version 2. This is the active HSRP router. Here's the virtual IP address that you'll see that they're both going to be using. Virtual MAC address, okay, that everybody's going to think is associated with this IP address. We can see the hello time, which is sent every 3 seconds between the active and the standby router. Hold time is 10 seconds. Again, if the standby router doesn't see a hello from the active router in 10 seconds, it will take over. Preemption has been enabled. It says, hey, the standby router is 192.168.1.2. That's its actual address over here. I have a priority of 200. Let's just take a look at show standby here, and we can see, I'm going to move this over here so we can actually compare the two a little bit. Okay, so you can see here that it's the interface on that side, happens to be the same interface number. Group 1 has to be the same version. We are standby. Same virtual IP address, right? Same virtual IP address. Same virtual MAC address. So the devices on the network just see it as one router. They don't care. Here's the hold time, preemption enabled. The active router, it's not me, it's 1.1 over here. And the standby router, local. When you see standby local, that means that's me. Just like here we saw active router local, that means it was R1. Okay, and my priority is 100. Oh, this is so cool. All right, we're going to do some stuff here. By the way, we can look at this in a brief mode by just typing brief. Show standby brief. It shows me, let me make that a little bigger. It just shows me briefly here, show standby brief, that my interface, my group, my priority, okay? I'm doing preempt. State, I'm the active router. Who's the active router? Me. Who's the standby router? Them. What's our virtual IP address? This. I can do the same thing here. You can see that they are this very similar. Gigabit interface. I'm in group 1, priority 100, lower than the 200 here, right? Preempt, I'm the standby. Who's the active? That one. I'm sorry, who's the active? That one. Who's the standby? Me. Virtual IP address, this is it. Same as the that the active router is using. All right, let's see this work. Now the fun stuff. Oh, but before we do that, remember what we have to do. All of our clients have default gateway. Let me go back here, show you how we do this. Services, DHCP. Okay. So remember, all of our clients have this as their default gateway. All right. I think I was showing this as the DHCP a little, or I was showing the config a little earlier. This is what we configured on this server. We want this server to go out. But what I want to show you here is services. Okay, DHCP. Got DHCP, default gateway. We got to change that. Okay, that's good. We want everybody to get 1.5. And I'm going to click save here. Okay, so that got saved. Matter of fact, there we go. We see it got saved. All right. But our clients, let's just go over to PCA here. And because right now it has the wrong default gateway. So I'm going to type IP config / renew. Let's get new addressing information. Really what we want here is this here, the default gateway. There we go. So we've got our new default gateway address. Okay, that's really what we wanted. Okay, should do the same thing PCB, but we don't need to here. All right, let's make sure that everything still works. Okay, before we test what happens when this link goes down, we're going to do that in a moment. Let's make sure it works under normal conditions without any problems. Okay, there's our ping to the server. All right, that's looking good. Matter of fact, let's do this. ARP, show you something cool. ARP -A. Look at this. Remember before we saw the default gateway was 1.1 and was the router's physical MAC address, but look, it's 192.168.1.5, and that's the virtual MAC address. Okay, I showed you that real quick. There's that virtual MAC address associated with the virtual IP address. Isn't that cool? So when it did the ARP request for the default gateway, which it now, right, 1.5, it got this MAC address from the router. This IP address and this MAC address won't change whether it's R1 or R2. That's the default gateway. Right now, the active router is R1. Okay, but as far as the host, it never has to worry about changing this. Okay, we're going to take care of this, or HSRP will. Okay, let's do one more thing. Let me just do a trace route so we can see. And this is very cool. Okay, notice that the trace route. Okay, it's going from PCA then to 192.168.1.1. What, Rick? Wait a minute, Rick. I thought you said the default gateway was 192.168.1.5. Why are we getting 1.1? This interface address and not the virtual address? I love this question because this is where it makes a difference between those that understand the protocols. A difference between those that do understand the protocols and those that don't. Okay, all you have to do is remember that walk yourself through this process. Okay, so when a trace route is sent, okay, remember a trace route is nothing more, well, in Windows, it's an ICMP echo request, a packet, encapsulated in an IP packet, and trace route sets that time to live to 1. Okay. The router receives, so it's going to, so by the way, it's going to its default gateway. Okay. It's going to the MAC address associated with its default gateway. It's going to this MAC address. Okay. Associated with PCA's default gateway. Okay. But when the router received it, it decremented the time to live by 1, which now becomes 0, drops the packet, and sends back an ICMP time exceeded message. So this router sends back an ICMP time exceeded message, and that's coming from its physical interface, 192.168.1.1. It says, I'm sending this not from my virtual interface, 192.168.1.5 that you care about, that IP address. I'm sending it out my actual, I shouldn't say physical interface, but the interface gigabit 001 with my actual IP address 192.168.1.1. So that's why we see this here and not 1.5. Okay. Just because it's coming, the message is coming from the router as an ICMP time exceeded message with the source IP address of this router's interface. All right. All right. In the lab, I actually have you look at the MAC address table. You can do that if you want on switch S1. And I talk a little bit about that, but it's not that important here. All right, so we have reachability, right? Okay, we can reach from PCA to server 0. Okay, what I'm going to do now is I'm going to send 1,000 pings from PCA to server 0. Okay, so I'm going to keep the network. That's really not keeping it busy, but -N 1,000. Okay, that's what that is. How many? The number. And I'm going to send it to 11.11.0.101, the server. All right. All right. So what I'm going to do here is send the pings, and then I'm going to shut down this interface right here. And we're going to watch that the failover happens where R1 is no longer the active router and R2 will become the active router. Let's take a look. Okay. So as I do this, I'm going to quickly go, I'm going to show you the output from both R1 and R2. So let's do this. Okay, so first I'm going to start with the pings here. I'm going to move this over here. I'm going to shut down the interface. Config T, interface gigabit 001, shut down. Okay, do shut down. See the link lights here go off. A couple of packets are going to get lost, but this is without me doing anything now. Within 10 seconds here, hey, the pings are continuing. Okay, we didn't do anything, did we? That link went down and we didn't have to touch anything. Okay, it took 10 seconds for it to recover. We'll talk about that in a moment, but everything's back up and going. Okay, I'm going to do Control C to get out of this. Let's see what happened here. When I did the shutdown, okay, so we could see that HSRP, state change, went from a NAC active to a NIT. Okay, it's basically kind of stuck in a NIT now because it's can't communicate with anybody. We can see that we also at the same time got a link change message that our gigabit 001 went administratively down. That's the shutdown. And there's our OSPF adjacency message. Okay, no longer have an adjacency here. So we see all this happening and we understand what's going on. Okay, now let's take a look at R2. What happened over here at R2? Okay, it got it noticed an HSRP state change. It waited 10 seconds without getting a hello message, HSRP hello message from the primary R1. Said, hey, after 10 seconds, I'm going to go from standby to active. Okay. Now it also noticed an OSPF adjacency change that it lost R1 as an adjacency. And this is the kind of things you can use to help troubleshoot what just went down, what just happened. Matter of fact, it even tells you the same thing here, neighbor down, interface down or detached. Yeah, we brought it down. Well, not the neighbor, but us here. Here, yeah, was the neighbor. Okay, the neighbor down. Okay, so help us debug what's going on. Okay, all right. So we saw that those continued. Let's take a look at a few things here. As far as PCA goes, and all of our clients, we never had to touch anything. I didn't have to change anything here. Still same default gateway. Didn't have to change that. Okay. Matter of fact, if I do ARP -A, yeah, same. There's our default gateway. Same default gateway. Same MAC address. So from the perspective of the devices on our network, besides a little hiccup, pause in packet forwarding, getting out of our own network, everything's back up and working fine. Let's do a trace route. Okay, now let's do a trace route to the server. We do see something different here. The ICMP time exceeded message is not coming from R1, but it's coming from R2, 192.168.1.2. Okay. Now let's take a look at those. Let me do those standby brief messages. We'll look at them side by side here so we can compare. Okay, so now if we look at R1, okay, we're still configured for HSRP on this interface. It's still a member of group 1, still that's its priority, still preempt, but it's in the init state because obviously its link is down here. Okay, who's the active? I don't know. I can't talk to anybody on that link because my link is down. Who's the standby? I don't know. I do know the virtual IP address because I was configured with that. Let's go over here to R2. Okay, running HSRP, group 1, priority 100, preempt. What's my state? I'm now active. Who's active? Me. Who's standby? I don't know. Not talking to anybody else on here via HSRP right now. And here's the virtual IP address. All right. But we do have reachability, right? Everything's working fine, right? Again, PCA, no problem pinging. We get that ping, I could send 1,000 pings now, no problem to the server. Okay, let's restore the fail point and see what happens. Now, remember, we configured the preempt option. Okay, if I can just go back and find that, the preempt option. Meaning if I have the highest priority and I come back online, I'm taking over again. Thanks for being active for a while, but I'm going to take over. So let's see that happen. Config T, interface gigabit 001. We'll do no shutdown. I can spell. Okay. Okay. Link, change state to up. Okay. HSRP, well, HSRP state changed. Okay. We became standby for a moment. Hey, we're active now. We're the active router. And OSPF says, hey, guess what? My neighbor's back up. Okay. Loading to full. Let's take a look at R2. Okay. So it says, hey, wait a minute, there's an HSRP state change. Okay. I am now standby. You'd actually see active. You'd see standby to active also. Why is it not showing that? I'm sorry, not standby to active. What you'd see is speak to standby. Yes, so it goes to speak mode, then standby. Excuse me. I'm looking at one thing and saying another. And there's a OSPF adjacency change. Yes, I got my old OSPF neighbor back. Loading to full with that neighbor there. Okay. And again, we can verify, show standby brief. Yes, state, active. Who am I? Or who's the active? Me. Who's the standby? R2. There's our virtual IP. Again, My state is now standby. The active is R1. Who's the standby? Me. And there's our virtual IP address. Okay, we're almost done here. Let's just make sure everything's still working. Okay, if I do that ping. Now it may time out the first one again, because it has to do, it has to do with the switch, MAC address table, and some stuff happening that I go into a little bit during the lecture. Okay, but we got success. Hey, let's do the trace route. See which path it's taking. We should see through R1, which we do. There's where the time exceeded message is coming from. All right. I hope you enjoyed this lab. It's one of my favorites to talk about. This is, something that gives us availability by providing some redundancy. Redundancy is fine. We can do this without HSRP, but let me remind us of what HSRP is doing for us. When this link went down here, we didn't have to make any changes. I didn't have to go over and change this router's IP address to be what everybody else thinks is what everybody else has on the network as the default gateway. Okay, all that takes time. And what if I live miles away? What if I'm not even in the same city or state as where this router is? Okay, so this all happens automatically. Okay, I remember, I've worked in places where they were 24/7, 24 hours a day, 7 days a week facilities. And, this kind of instant failover, you want it to be able to automatically fail over for you without having any kind of network engineer intervention. All right, hope you enjoyed this lab. Have a great rest of your day.